In this quick lesson, we're going to look at how to integrate e to the minus x sine x with respect to x. So we're going to start by letting I equal our integral of e to the minus x sine x dx. And we'll see later why we've done this. Now to integrate this, we've got two functions, e to the minus x and sine x, within our integral. And quite often when that's the case, a good rule to use is integration by parts. This is especially good when one of them is easy to differentiate and the other one's easy to integrate. The formula for integration by parts is the integral of u times dv is equal to uv minus the integral of v du. So if we let u equal e to the minus x and dv by dx equals sine x, differentiating e to the minus x and integrating sine x gives us minus e to the minus x for du by dx, and it gives us v equals minus cos x. Now putting this into our formula, we get that I is equal to u times v, so e to the minus x times by minus cos x, minus the integral of v du, so minus cos x times minus e to the minus x. Simplifying this, being careful with the negatives, gives us minus e to the minus x cos x minus the integral of e to the minus x cos x dx. Now this integral isn't any easier to do than what we started with, but we can use integration by parts again. So very similar to before, but this time we've got a cos x instead of the sine. So we're going to let u equal e to the minus x, dv by dx equal to cos x. Differentiating u gives us minus e to the minus x. Integrating dv by dx gives us sine x. And putting into our formula means that this second part is equal to e to the minus x sine x minus the integral of minus e to the minus x sine x dx. So getting rid of our negatives, dealing with the brackets, gives us that I is equal to minus e to the minus x cos x, which we got before, minus e to the minus x sine x minus the integral of e to the minus x sine x dx. But if we look carefully at this integral at the end is the integral that we started with. It's I. So let's replace this with I. And if we add I to both sides, we get that 2i is equal to minus e to the minus x cos x minus e to the minus x sine x. Dividing both sides by 2 and factorising the minus e to the minus x gives us that I equals minus e to the minus x over 2 times by cos x plus sine x. So there we have it. The integral of e to the minus x sine x dx is equal to minus e to the minus x over 2 multiplied by cos x plus sine x plus c. If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.